Okay, so far what we have is forces or components that were at right angles to one another. Regrettably, that's not usually what we see. So you see here in this figure that we have one tugboat pulling a barge all in the x direction and one pulling it at an angle alpha between the x and the y direction. So if we want to find the resultant of those two forces, right now we don't have a method to do that. Okay, so here's the step-by-step method. You need to break each force into its components, x and y. Well, P2 is only going to have an x component. All right, P1 will have an x and a y component. Then you want to add all the components, x components up. Then you'll add all the y components up. You can find the magnitude of r just like you have before and find the angle of r. All right, so that's kind of where we're going. Okay, so here's our first example. We have two forces, F1, 350 newtons, F2, 300 newtons, and first thing I need to do is break them into their components. So let's try to do this. All right, F1 okay, well, let's see, having a little trouble here. Is going to be equal to F1 times the cosine of the angle, okay? And we're just going to call that A. Alright? So when we look at that, okay, the problem is I don't know angle A. Alright? So how am I going to find angle A? Well, I know that the triangle here, okay, like this, is in the relationship of 5 on this side and 12 on that side. Alright, so I also know then I can find this angle, right? So let's do that. The tangent of A is going to be equal to the opposite divided by the adjacent, which is going to mean the tangent of A is equal to, oh, well, that's not really A. Let's call that one B. Sorry. Okay, the opposite in this case is 12, and the adjacent is 5. Alright, so that means that B is going to be equal to the arctan of 12 divided by 5. And so when I plug that into my calculator, I get B is equal to 67.4 degrees. Okay, so what does that mean for us in terms of A? It means that A is equal to, angle A is equal to 90 degrees minus 67.4 degrees, which is going to be equal to 22.6 degrees. shoot. Okay? Alright, so now we can go back and get f1x. Alright? So is equal to 350 newtons times the cosine of 22.6 degrees. When I plug that into my calculator, I get 323 323.1 newtons. Alright, so I can do the same thing with F1y. It's F1, oops, times sine A so that's going to be equal to 350 newtons times sine 22.6 degrees and I get 134.5 newtons. Okay, now also remember that while this was in a positive x direction, the y component of that force is a negative. So we need to be sure that we keep track of that negative, and we put it in. It's going in a negative y direction. Right? And so now we've broken our first force into components. Okay, we'll need to do the same thing with our second force. Okay, and so we'll say that that angle is cosine is C, so it's going to be F2 cosine C, right? And that'll be 300 newtons times cosine 60 degrees, which is going to be equal to 150. Alright, so the other thing is though, that's a negative x direction, so we can't forget that. We go back, put my negatives in. Alright, now let's do F2y. Is equal to 300 newtons times the sine of 60 and when I plug that into my calculator I get 259.8 newtons, and that's positive. Alright, so now if I add the x components and I add the y components, I can get Rx and Ry. So let's do that. This is going to be F1x plus F2x. Okay, So that's going to be equal to 323.1 plus, the next number is negative, a negative 150 newtons. So Rx is going to be equal to 323.1 minus 150, 173.1. Okay, then let's do Ry. It is F1Y is negative 134.5 plus 259.8, and so Ry is equal to 125.3. And that's newtons. Okay, let's just think about what our answer means for a second. Okay, this number is positive and this number is positive. So which quadrant is our answer going to be in? This one. All right. Okay, so let's find the magnitude of R. R squared is still just Pythagorean, so it's Rx squared plus Ry squared, so it's going to be equal to 173.1 squared plus 125.3 squared. So let's see what we get. Alright, I get that is 45,663.7. That's newtons squared. Okay. To find R, I take the square root of both sides, and I get 213.7 newtons. Alright, I still don't know the magnitude, so I will do my tangent relationship. The tangent of, we haven't used, we'll do D, is equal to Ry divided by Rx. So D is the arctan of Ry divided by Rx let's substitute these numbers in. Oops. Okay, so plug into my calculator and get D is equal to 35.9 degrees. Right? And that's our answer. So the answer we're looking for is This is the magnitude of r. We have to have a direction to define. Okay? Okay, let's work the next example. To do this, we're going to have to break all 4 of these forces down. So let's label these forces. 1, 2, 3, 4. Okay? And we're going to be using the general form Fx okay? The Fx is equal to F cosine of theta, and Fy is equal to F sine theta. Okay, now that's only, those formulas are true when our theta is measured from the x-axis. Alright, so let's go through and find the components of each force. Okay, F1x is going to be equal to 8 kips times cosine of 25 degrees. So F1x is going to be equal to 7.25. Okay, F1y is going to be equal to 8 kips times sine 25. So F1y is equal to 3.38. Kips. Both of those are positive because it's in the positive quadrant. Okay, F2x is going to be equal to 12 cosine 30. F2x is 10.39 kips. F2y is negative because it is in a negative y quadrant. So it's going to be 12 negative 12 sine 30, and F2y is equal to negative 6, I think, is 6 kips. Okay, F3x is going to be negative because you see here it's in a negative x quadrant. Negative 5 cosine 50. And F3x is 3.21 kips. Don't forget that's negative. Okay, F3y is going to be equal to, it's a positive number, it's in a positive 5 sine 50. So F3y is equal to 3.83. And finally, let's do F4 is equal to 10 kips. So let's start with the x just like we have every other time. And that's going to be negative because it's in a negative x quadrant. It's also going to have a negative y component because it's in a negative y component. But quadrant, it's going to be 10 cosine 60. So F4x is going to be equal to 5 kips. That's negative 5 kips. And F4y is equal to 10 sine 60. It's also negative. So f4y is equal to 8.66, negative 8.66 kips. Alright, so now Rx is going to be equal to 7.25 plus 10.39 plus the next one is it's a negative, let's see, 3.21, and then the next one's going to be plus, and it's also a negative, negative 5. Alright, and so when I add those up in my calculator, I get 9.43 kips. Okay, Ry is going to be equal to 3.38 plus a negative 6 plus f3y is 3.83 plus a negative 8.66 so we get our y is going to be oops, I see a mistake right there, an extra plus sign, and so that makes my Ry equal to negative 7.45 kips. Alright, Rx, this one's Rx. Alright, so we've got a positive x and a negative y, which means we're going to be here in this quadrant. So let's say our r is equal to the square root of 9.43 squared plus negative 7.45. Oops, I forgot to turn my superscript off. Plus, this is just Pythagorean again, and I used SQRT to be square root. The square root of, what was it? Negative 7.45. Okay. Now remember, when we square that negative, it goes away. So let's go ahead and calculate this out. Okay, and I end up with R equals 12.01 kips. And let's remember, tangent of our angle, we'll just say it's A this time, is equal to Ry divided by Rx. So A is equal to the arctan of ry divided by rx. So A works out to be this time, oh, how'd I end up there? Okay, A is equal to, ry was 7.45. Now I'm not going to use the negatives because all that's going to happen is they'll give me a negative angle, which would be the angle going back this way. But I know that it's in this quadrant, okay, and I'm going to draw it so that you can see that. All right, divided by 9.43. There it is. Let me type those numbers in so you don't forget them, what they are. That was 7.45 divided by 9.43. All right, and I got 38.3 degrees. Okay, so now I have completely answered. I have the magnitude, I have the angle, okay, and that works out to be something that looks like this. Okay, and it's in the positive x quadrant. We had positive x, and it's in the negative y quadrant. We had negative y. Okay, so there you go. That is finding a resultant from multiple angles.